This is the third question on 8EEB5. On this one, we're going to graph a proportional relationship, interpreting the unit rate as the slope of the graph. What we're actually going to do is we're going to take the graph that's here, and we're going to write the linear equation from it. If we look at this, this says Liam's office uses a high-speed laser printer. On the graph below, the line shows how the printing time varies proportionally with the number of pages being printed. See how it starts at 0 and it moves up. On the y-axis, we have the number of pages printed. On the x-axis, we have the time. Always read your axes first to figure out what you're talking about. Write an equation that represents the rate of change of the printer. Write an equation. Here's what they want us to do. Let's underline what they want us to do. This is the first thing they want us to do. Write an equation that represents the rate of a printer that prints at a faster rate than the one used in Liam's office. Using P to represent the number of pages, so P equals number of pages. Making myself notes. And T represents time, okay, in minutes. Explain how you know it must be faster. Well, to decide if it's faster, to write ones is faster, first I need to figure out what the rate is here. So let's write the linear equation for this one. Y is equal to mx plus b. Now let's notice our b is 0 because the y-intercept for this is at 0. There's your y-intercept where it crosses the y-axis. If our b is 0, it does not matter. So we're just looking at y is equal to mx. We need the slope. We need the rate of change. We need the change in y over the change in x. That's your rise over your run, your rate of change. Now, to do that, let's find places where this crosses the line. This is very obvious where it crosses here at 5. Let's go with this 5. I'm going, let's do our rise over our run. I'm going up and over. There's our right triangle. I didn't draw it very well, but that's what it's supposed to be. A right triangle there. Okay? Now, how much did it go up? It went up to right here. Let's look at our units. Between our 300 and 400, let's see, we've got 1, 2, 3, 4. If I take this 100 between these two and divide by 4, that means each one of these units is 25, right? So if this is 200, this is 225. I'm going up 225 pages. That's my y-axis. How many minutes? See, minutes is on the x. How many minutes am I going over? 5 minutes, okay? So this is 225 pages per 5 minutes. Let's find the unit rate on this. Let's divide 225 by 5. Put it in your calculator. And if you do, you're talking about 45 pages per minute. Okay, that's the rate that Liam's Liam's printer prints at. 45 pages. And this is a unit rate for us. 45 pages per minute. When you're talking about 1 on the bottom, 1 denominator, it's a unit rate. This is also our slope, our rate of change. We want one that goes at a faster rate than his. Well, if it goes at 45 pages per minute, why don't I go to 46 pages per minute? Why don't I use that as our unit rate? That would be more than 45 pages per minute. Write an equation that represents this. So the total number of pages that we would have would be equal to 46 pages per minute times the number of minutes, right? This would be our equation. This gives us something that's faster. Why is it faster? Because printing 46 pages in 1 minute is more pages per minute and printing 45 pages in 1 minute.